All right, this video is going to just pretty much recap everything that we've been talking about with Taylor polynomials so far. And we're going to start with some vocabulary. First of all, when we talk about the degree of a Taylor polynomial, that's just the highest exponent of the polynomial. The order of a Taylor polynomial is the highest derivative used to compute the polynomial. And sometimes those are the same thing. Actually, a lot of the times, those are the same thing. The degree is the highest exponent, the order is the highest derivative. So if we look at that last one we just did, well, let's just say we stopped at to the fourth power here. We stopped there. That fourth power is the highest degree. It was also the fourth derivative. So in this case, the order and the degree are the same thing. Most of the time, that's true. But knowing that the degree and the order are different things, it's going to come in handy. So these four Maclaurin polynomials are the polynomials you just must know. Just like you know that tangent is sine over cosine. Just like you know that sine squared plus cosine squared equals 1. You better know those two things anyway. These are four Maclaurin polynomials you just need to be able to pull off the top of your head. If you have to configure these every single time, that's going to kill precious time, especially if we're looking at like recognizing one of these on an FRQ. Time is of the essence. So knowing these is really, really important. Okay, so these are four that you just need to know. These other four are those that you just need to be able to find. So, well, it's not showing all four at the same, there we go. You need to be able to find these. So I'm going to give you a moment. I want you to pause this and see if you can somewhat quickly, so thinking about making new polynomials from old polynomials, can you write the Taylor polynomial, or Maclaurin in this case? We're going to center all of these about 0. Can you write the Maclaurin polynomial for each of these four? Pause, go do it. Okay, so this first one looks to me like it's looking like a geometric series. So I'm going to rewrite this as 1 over 1 minus negative x squared. So what that tells me then is that the first term in this geometric series is 1, and the ratio is negative x squared. So the polynomial for 1 over 1 plus x squared then is the first term multiplied by r, so that's negative x squared, multiplied by r again, it's x to the fourth, multiplied by r again. And I want you to write the general term for these. So if you didn't do that already, pause again and go write the general term and write this to infinity. So it looks like we've got an oscillating positive and negative signs. We'll do negative 1 to the n since the first term is positive. And then it looks like the powers are going to be even numbers. So this is x to the power of 2n. You should be getting better and better at recognizing those patterns. So right now we have found a Maclaurin polynomial for 1 over 1 plus x squared. Something you need to be able to find also fairly quickly. Okay, the natural log of 1 minus x. Well, we know 1 over 1 minus x. That was one of those you just need to know. That's 1 plus x squared plus x cubed and I also know that the antiderivative of 1 over 1 minus x is almost the natural log of 1 minus x. That's pretty darn close. The natural log of 1 minus x is equivalent to the negative antiderivative of 1 over 1 minus x. So thinking about u prime over u, if u was 1 minus x, u prime would have been negative 1. So the antiderivative of the natural log, or of 1 over 1 minus x, is the natural log of 1 minus x. So let me see if I can write this a little bit more clear, because I feel like I'm talking in circles. So the natural log of 1 minus x is equal to the negative, the opposite, of the antiderivative of 1 plus x squared. Okay, so if we find the antiderivative of each one of those terms, then antiderivative of 1 is x, 1/2 x squared, 1/3 x cubed. That would have been 1/4 x to the 4th. So to find the antiderivative of x to the n, we're going to add 1 to the exponent and divide by that exponent. But now I need to distribute that negative in. I'm taking space from my next one. That's okay. Negative x minus 1/2. I'm going to write this as x squared over 2. Okay. So that's one way to find it. Now, I bet you can find the natural log of 1 plus x. If you haven't done that already, why don't you pause this? After I did that last one, why don't you pause this and see if you can find that polynomial for the natural log of 1 plus x. Because I think after what I just did, you might have a little bit of an easier time. I'm going to leave myself some more space. I'll come back to the arctangent in just a moment. So what we need to find first is because I know that the antiderivative of 1 over 1 plus x is indeed the natural log of 1 plus x. So if I can find the Maclaurin polynomial for 1 over 1 plus x, I can find the Maclaurin polynomial for the natural log of 1 plus x. So 1 over 1 plus x is also a geometric series, 1 minus negative x. So I know that a is 0. I know that r is negative x. So I can write the Maclaurin polynomial for 1 over 1 plus x. That's 0. Why did I say 0? A is 1. Sorry. I was thinking a sub 0. 1 times negative x, multiply by negative x again, multiply by negative x again. So this is oscillating. Okay, then the natural log of 1 plus x equals the antiderivative of 1 over 1 plus x, which is the antiderivative of this Maclaurin polynomial. All right, if we write the antiderivative of this, then I end up with x minus 1/2 x squared, or x squared over 2, 1 plus 1/3 x cubed, minus 1/4 x to the 4th. So notice that our negative 1 to the n didn't change. That was just a constant. That was a coefficient. But the x to the n did. This is 1 degree higher. Okay. Finally, for the last one then, arctangent x. This one's going to be a little bit more tricky. You have to remember the derivative of arctangent x in order to find the antiderivative of arctangent x. Well, I know that the derivative of arctangent x is 1 over 1 plus x squared. So arctangent x is the antiderivative of 1 over 1 plus x squared. And the nice part is that the very first problem we did in these ones you must be able to find, that was already 1 over 1 plus x squared. So I know I just need to find the antiderivative of 1 minus x squared plus x to the 4th minus x to the 6th, negative 1 to the n, x to the 2n. Okay, so the Maclaurin polynomial for the arctangent of x is x minus x cubed over 3, x to the 5th over 5. So these become odd exponents now instead of even. This becomes x to the 2n plus 1 over 2n plus 1. All right, that's the introduction to Taylor polynomials. That's finding a polynomial. We're going to use these a lot more. This is really good to be able to write the polynomials so that we can then use them for other purposes. So I'll see you in